It is the closest planet to the Sun, and yet it hides in plain sight. Mercury, smallest of the 8, swiftest of them all. 1 year here lasts only 88 Earth days. It circles our star at over 170,000 kilometers per hour, faster than any other planet. It races through space, locked in a gravitational dance with fire. At its closest, Mercury is only 77 million kilometers from Earth. In the cosmic sense, a neighbor, closer than Jupiter, far closer than Saturn. A trip that seems so simple, but reaching it is among our hardest challenges. Why? Because falling toward the Sun is not like flying into the void. It is fighting gravity with gravity. It is resisting acceleration. To reach Mercury, you must first slow down. Slow down enough to drop inward toward the Sun, yet not so much that you're flung past it. In context, it took NASA's Messenger 7 years and 6 planetary flybys just to enter orbit. The Sun's gravity is relentless. It pulls every spacecraft toward its furnace. To resist it, we borrow speed from Venus, from Earth, from every sling and spin we can muster. And when we finally arrive, what do we find? Mercury is a world battered by time. It bears the oldest scars in the solar system. Craters stacked upon craters, a fossil record of impacts stretching back nearly 4 billion years. The Caloris Basin, one of the largest impact sites in the solar system, so vast it could hold the state of Texas twice over. Created by an asteroid slamming into Mercury with such force, it rippled the other side of the planet. Mercury's crust, once molten, buckled and shrank as the world cooled. Mountains and ridges formed as it contracted, a planet literally shriveling as its heart solidified. Mercury has no true atmosphere, only a whisper, a thin exosphere of helium, sodium, and hydrogen. Without air to trap heat, temperatures swing wildly. In the daytime, Mercury bakes at 430 degrees Celsius, hot enough to melt lead, hot enough to burn spacecraft electronics in minutes. But at night, the heat escapes. Darkness falls, and the temperature plummets to -180. And in its polar craters, where sunlight never touches, ice hides, silent, untouched, preserved in shadow. How does ice exist on a planet so scorched? Because even in hell, there are corners the fire cannot reach. In the deep shadows of polar craters, ice survives. Even here, in fire's domain, some corners resist the heat. For a long time, scientists believed Mercury was a dead rock, cooled and solid, but they were wrong. Mercury has a magnetic field, weak, yes, but real. And to have a magnetic field, it must still have a partially molten iron core. And what a core it is! Massive, accounting for nearly 85% of the planet's radius. Mercury is less a rocky world than a metal one, cloaked in crust. It may be the most iron-rich planet in the solar system, and still, perhaps, alive beneath the surface. Mercury's magnetic field proof that something inside still moves. Its iron core, vast and mysterious, may still churn. Could we ever walk on Mercury? Could we ever build, survive, thrive there? The answer is likely no. The heat is relentless. The radiation, unfiltered, constant, lethal. There is no air, no protection. And then there's the sun, hanging always nearby, growing, rising, never setting in some parts of the sky. Mercury's slow rotation creates bizarre sunrises. The sun seems to pause, even move backwards, before resuming its rise. It is beautiful and terrifying. Could we land robots here? The answer is absolutely, because we have. But could we build shelters, shielded bases, science stations nestled in polar craters? Perhaps one day. But colonize Mercury? The cost of survival may far exceed the reward. Mercury is the swift messenger, the iron orb, the sun-scorched world on fire. We rarely look its way, but it waits, enduring, ancient, a relic of the solar system's birth, still racing round the flame. Thanks for watching. Kindly subscribe to our channel and hit the notification button to be notified immediately we premiere the next episode. Do leave a comment on what you think about this video and tell us what you think we should implement in our upcoming videos. Thanks, bye for now.